For the longest time, REST has been my go-to, sorry Dijkstra, architecture for building APIs. And I've had little to no complaints. However, REST hasn't been the only API architectural pattern that I've used, with the other major one being RPC. RPC comes in a number of different flavors, such as JSON RPC, HTTP RPC, and the main one we're talking about in this video, gRPC. Before we talk about it, however, let's look at what RPC actually is. RPC, which stands for Remote Procedure Call, is a form of inter-process communication. It works over HTTP, similar to REST, but instead of being resource-based, it works with actions. For example, let's say you want to create a new Pokemon in a Pokemon-based API. With REST, you'd send an HTTP request with a post method to the /Pokemon endpoint, with your Pokemon details in the request body. If we want to do the same with JSON RPC, we'd instead send an HTTP post request to a generic endpoint, with the following request body, specifying both the action or method that we're taking, in our case create Pokemon, and the data in the form of the params field. Now I know what you're thinking, why would anyone choose this over REST? And you're correct. Creating resources isn't the best example of using RPC. A better example would be an API for a calculator service. In this case, it's actually rather difficult to model a RESTful API. And that's because of the lack of any tangible resources or objects for us to model a RESTful interface around. Instead, calculators typically perform actions, such as addition, subtraction, multiplication, and division. In an RPC interface, these methods are incredibly easy to model. In fact, it's why Slack decided to model their API using HTTP RPC instead of REST. Whilst their API does have the concept of objects, they mostly have methods. And ultimately, that's where RPC shines. So whilst it's not its most optimal use case, you can use RPC to create and manage resources, which when compared to REST, gives a lot more flexibility for a service's API. Whilst this does imply that RPC is more powerful, there is one major drawback. This drawback is the lack of self-documentation. For example, if I told you I had a well-designed RESTful API that managed dragons, there's a good chance you'd figure out how to use it even with little documentation. The same can't be said for RPC, however, which is why I've always opted for RESTful APIs in the past. That is until gRPC came onto the scene and brought with it one fundamental change. That change is protocol buffers, or protobuf for short, which is a language-neutral, extensible mechanism for serializing structured data. It's similar to XML or JSON, but with one key difference. It's a binary protocol instead of a text-based one, which gives it the benefit of being more compact. However, in order to accurately decode a protobuf payload, you require the schema that was used to encode it in the first place. You might be thinking that this sounds like a drawback, but in reality, it's actually a strength. The requirement of the .proto file acts as a sort of contract for an API. So what does a protocol buffer schema look like? Well, here is one for a calculator service I've created already. This probably doesn't make a lot of sense at this stage. So instead, let's look at a service in action that uses this contract. To do this, we're going to need an instance of our calculator service to interact with. Fortunately, I have one which you're able to deploy an instance of yourself, for free, using the sponsor of this video, Acorn. To deploy it, all you have to do is click the deploy link in the description down below. Then sign in with your GitHub account, click the deploy button, and it'll create an ephemeral instance of the service for a couple of hours. No cost, no code to run, which is much more secure than running locally, and it has all of the infrastructure you need to test with. It's a really cool product which allows me to easily share deployments with you for free. We'll talk a little bit more about Acorn later on, but for the moment that's all you need to do. After a short while, you should get back the URL of your deployed instance. Make sure to take a note of it, or copy it to your clipboard. The next thing we're going to need is a gRPC client. For this video, I'm going to use gRPC UI. One, because it's open source, and two, it seemed to work best for some certain use cases. However, you may want to use an app like Postman or Insomnia yourself. Either way, make sure to first install your chosen client as per your operating system. Once installed, you'll then want to connect to your deployed service using the URL that was generated earlier. If you're using gRPC UI like I am, you'll want to remove the HTTPS from the start of this URL and add the port of 443. When the UI opens, the first thing you'll notice is that all of the RPC methods are populated. This is done using reflection, which is an opt-in feature of gRPC. It's not recommended to enable it on external-facing services, but for our test server, it saves us having to mess around with any .proto files until we learn a little bit more about them. Let's go ahead and call the add method of our service. All we need to do is select the method, fill in the required parameters, which are the two numbers we're going to send, and send off the request. We'll get the result of our two numbers added together, showing that everything is working. We can do the same with any of the methods that our service provides. This is pretty cool and shows the strength of having a contract associated with our service, which is really difficult to achieve for the other types of RPC. To do so, you'd need to define your contract using something such as an OpenAPI spec, which isn't the nicest thing to write. Then you can load the OpenAPI spec into a OpenAPI UI and get something similar. However, there's a catch. Your OpenAPI contract isn't always guaranteed to match your actual service. So even then, you need to add contract testing into your API to ensure parity with the OpenAPI specification. All of this is a lot more work and maintenance just to get to the same feature set that gRPC gives you for free. So now that I've hopefully convinced you of the benefits of gRPC, let's take a look at actually building our own version of the calculator service we were just using. Both protobuf and gRPC themselves are language agnostic, but I'm going to use Golang in this video as I feel it does a good job of showing the end-to-end process. If you want me to do a video on gRPC in a specific language, then please let me know in the comments down below. Let's begin by creating a new directory and initializing our project using gomod init. Next, we'll want to create a folder called proto with a file inside called calculator.proto, which we'll then open up in our editor. The first line of this file is used to specify which version of protobuf we're using. In our case, proto 3. The next line is used to name the package of our protobuf file. I'm going to call mine calculator. Then we define our actual service, which again is called calculator. Inside of the service block is where we're going to specify the RPC methods that our service provides. We do this by using the RPC keyword followed by the name of the method. In this case, we're defining the add method. We then specify the inputs for this method inside of the parentheses. Here, our input is called calculation request, which we're going to define in a minute. Next, we'll add the returns keyword followed by the type we wish to respond with. We've named our type calculation response. Let's go ahead and create both of these types. In gRPC, types are known as messages, and we can define one with the message keyword followed by the name we wish to give it. Here we're creating a message called calculation request. Inside, we then need to define the body of this request, known as the fields. Let's add our first field, which will be the left-hand side of the calculation. The first thing we need to define is the field's type. In our case, we want to set this to be an int 64. After the field's type, we can give the field a name. We'll call ours A. Lastly, we need to set a field number. This number must be unique across the fields inside of a message. Let's go ahead and set this to the number 1. We can now do the same for the right-hand side of the calculation called B. With our request message defined, let's go ahead and do the same for the response message. Inside, we'll define a single field called result, which is of type int64 and has a field number of 1. Lastly, we just need to add in the following line, which is an option when generating Golang code. This option will specify which package we want our generated code to reside in. Once that's done, go ahead and save the file. With our service defined in protobuf, we can now use it to generate some gRPC code. To do that, we first need to install a couple of tools. The first tool is proto-C, which is the protobuf compiler. This can be found in the protobuf package. Next, we need to install our language-specific plugins. For Golang, that's the following two packages, proto-cgengo and proto-cgengo gRPC. These can be installed through Golang using the go install command or through your operating system's package manager. I've also left instructions on the GitHub repo for this video. You can find the link to it in the description down below. With that done, we're now ready to generate some code. To do so, we just need to run the following command in our terminal, which will load all of the .proto files in our proto directory and generate both Go models and Go gRPC code. This command is a little bit gross to type, however. It's usually a good idea to add a makefile or something similar so that we don't have to keep typing it out. To do so, create a new makefile in the project and add in the following lines. Now we can run make generate inside of our project directory and our protobuf will be created for us. If everything worked correctly, you should have a directory or package called pb, and inside of it we should see our generated code. Now we're ready to go ahead and use this to create a service. The first thing you'll want to do is install the gRPC package from Google using the go get command. Once that's completed, create a new directory called server, and inside add a new file called main.go. Opening this up, let's define our package and create an empty main function inside. Now we can begin creating our server. Let's first define a new struct called server, which inherits from the unimplemented calculator server found in our pbcodegen package. Make sure to import both this and the context packages. Next, we need to define our add method. We can do so by using the following function definition, which accepts a context.context and a pb.calculation request. Finally, we'll return our response type of pb.calculation response and an error if one exists. The actual function itself is pretty easy. We'll just return a response which contains the sum of our two numbers and a nil for the error. Pretty simple. All that remains is to load up our server inside of our main function. To begin, first import the following 4 packages. Then scroll down to the main function and create a TCP listener to listen on port 8080, followed by creating a new gRPC server type. Let's also add in the following line to enable reflection, which we'll want for testing at this time. We then just need to register an instance of our calculator server to the gRPC service, which will then serve using the TCP listener we just created. As a note, it's worth mentioning that gRPC only works over HTTP 2, rather than HTTP 1.1, which is why we're using a TCP listener. Now, if we run this code, we can test everything is working by connecting to it with our gRPC client using the following command. If we go ahead and test our add method, we can see that everything is working as expected. So far, so good. Let's go ahead and get this deployed to the cloud before we add any more functionality. To do that, we're going to need a Docker file. Let's create a new one and add in the following lines. This will build our app using Go 1.20, and we'll use a different Docker stage in order to run the binary. With the Docker file in place, we can now test that everything is working by opening up a new terminal window and running docker build. Next up, I'm going to show you how to get this running on Acorn. To do so is pretty simple. We first just need to download the Acorn CLI to our machine, which you can do pretty easily using Homebrew on macOS or following the documentation on Linux. With the CLI installed, we can then call the acorn login command to log in to Acorn Cloud. We should get a success message letting us know that we're in. Now that we're logged into Acorn, we can go ahead and start writing our Acorn file. This file is basically a really simple way to declare complex applications, which when pushed to the Acorn platform, will spin up the environment as we've declared it. Inside of this file, we'll declare a container for our calculator, which will build the local Docker file. We'll then expose port 8080 with an HTTP 2 interface, which is needed for gRPC. To then deploy this, all we have to do is call acorn run and pass in the name we want to give to the app. Acorn will then build our app for us and deploy it, providing us with the URL of our deployed application. If we then take this URL, we can use it with our RPC client. When testing this for the first time, I received a context cancelled when trying to connect, most likely due to DNS propagation. I haven't seen that error come up since, so if it does happen to you, just wait a few seconds and try again. Connecting to our server, we can see our add method is available for us to interact with, and works as expected. So this is great. We've just managed to create our first gRPC method. The method we created is pretty simple and isn't likely to fail, but what about a method that could cause an error? How would we handle it? To understand error handling in gRPC, let's look at implementing the divide method of our calculator service. To do that, head back on over to the calculator.proto file and add in a new method called divide. This method will accept the same calculation request and return a calculation response. Let's save this file and use the make_generate command we made earlier in order to regenerate our code. Now let's head back into our main file and implement this method. We'll do this naively at first, which is just dividing input A by input B. Pretty simple. Now let's run this interactively on Acorn using the acorn run command with the I flag. To test our divide method, I'm going to use gRPC curl, which is a CLI tool for sending gRPC requests, as you would curl. If we call our method with an input of 10 and 2, then we get back the result of 5, which is expected. However, what happens if we try to divide by 0? Well, it crashes the server. Not great, but this is also expected. Bad input is a common problem when it comes to APIs, as you can never really trust the client, ever. So our service needs to validate the input and return an error if there's something wrong with the values. In a RESTful API, this error would look like a status code of 400 being sent back to the client, with perhaps an error message letting them know what went wrong. When it comes to gRPC, however, things are a little different. As our service is backed by a contract, we can't be loosey-goosey about what we send back to the client. So what do? One approach could be to define an error message within our protobuf schema, and we could then add it as an optional field in our calculation response. This means we'd also need to define our result as optional as well, given that our response would only ever contain an error or a result. This approach is a little clunky, however. We'd also have to repeat this for every response message we defined. Luckily for us, there is a better way. Let's jump back on over to our implementation code in the main.go file. In order to handle our error, let's first import the codes and status modules of the gRPC package. Next, scroll down to the divide method's implementation. Let's first add in a check to see if the divisor, the right-hand side, is 0. If so, then we want to return an error in the function, which we can do using the status.error method. This function expects both a status code and an error message string. The code most applicable to our situation is the invalid argument error code, and we'll set the error message to be cannot divide by 0. Let's now redeploy this code on our server in order to test it. Whilst Acorn is running in interactive mode, if we run the touch command against our Acorn file, it will automatically rebuild and deploy our project for us. Once it's done, we can go ahead and rerun the gRPC curl command against our server. As you can see, the server no longer crashes and the client receives a response telling it what went wrong, which provides a much better developer experience when consuming the API. So that almost wraps up our gRPC server, but there's one last thing to look at before we begin implementing our client. For this final task, we want to add a new method called sum, which will accept a list of integers and return the sum of them all. To do this, let's head back on over to our calculator protobuf, and we'll add in a new RPC method called sum. This method will take a new input message, which we're going to call numbersRequest, and it will return the existing calculation response message. Now we can define our numbersRequest. In order for this message to contain a list of integers, we can use the repeated keyword on a field, which tells protobuf we expect this type to be a list containing 0 or more values. With that, we're ready to generate our code. Opening up a new terminal window, let's go ahead and run make generate to generate our code and then start implementing this new method. This should be reasonably familiar at this point. The only difference is the new type that we've defined. For this implementation, we're just going to iterate over the numbers in the input array and return the response. Now let's go ahead and redeploy this using the acorn run command with the update flag. We can then test this new method using either the gRPC UI or gRPC curl. When using gRPC curl, we're setting the numbers as we would a JSON array. When we invoke our request, we receive the result we're expecting back, telling us that everything is working as intended. That wraps up our calculator service, but we're not finished yet. So far, we've been using pre-made gRPC clients to interface with our server. But in the real world, we're going to want to use a gRPC client within our code. Fortunately, whenever we generate code with the protobuf compiler, we also generate client code that we can use. Let's look at how to do this. To begin, let's first create a new directory called client in our project, with a main.go file inside. Opening up this file, let's add in the package name, import the packages we're going to use, and define our empty main function, which we're going to fill in. First, we'll specify a CLI flag so we can set the server address when we run our code. The next few lines are used to enable TLS, which we're going to need when deploying to Acorn. If you're running this locally or deploying without TLS enabled, check out the source code on GitHub for how you can disable this. Next, we'll want to create a gRPC connection using the dial method of the gRPC package, passing in both our server address and the gRPC options. Let's handle any errors and add a defer to close the connection when our main function is complete. This code creates the basic gRPC connection for us, which we can now use with our generated protobuf. To do so, import the pb package which contains our generated code, and then create a new instance of the calculator client, passing in the connection. With that, we can now call our RPC methods using this connected client. Here is how we would call our recently implemented sum method, making sure to also use our generated types. With our code completed, let's go ahead and run this using the go run command, making sure to pass in the URL of your deployed service. You should get back the following response, letting you know that everything worked as expected. With that, we've managed to create both our calculator service and client, all using gRPC and protobuf. I've intentionally left out these subtraction and multiplication methods as an exercise for you to complete, as you should have all of the building blocks available to do so. Before you go off and do that, however, I have one last thing to show you. Whilst I've given you the building blocks of gRPC, you may be interested to know what a gRPC CRUD app looks like. So I've created one that you can reference. This is yet another Acorn app that you can deploy yourselves, which also integrates with Postgres for persisting data. You can find a button to deploy this yourself in the video's GitHub repo, which is linked in the description down below. This repo also happens to contain the code itself if you want to reference it. This CRUD app provides all of the operations for creating, reading, updating, and deleting Pokemon. The one feature I really want to show is inside of the create method. If you look at the request data, you can see we have an ID field, a name field, and a type field, which is an array. If I go to add a new item to our type array, you'll see that we're presented with a drop-down list. This is done using an enum in our .proto definition. which allows us to easily constrain the possible inputs, providing us with a greater level of type safety. Whilst it is possible to achieve this using a RESTful API, it's much harder for us to communicate that enum representation to our clients. At this point, you may feel like I'm saying gRPC is superior to REST, and in some ways it is. But even with everything I've said in this video, there are some drawbacks to using gRPC. Some of these drawbacks include the lack of a mature ecosystem, difficulty when introspecting data, and the lack of native web support. However, more and more solutions are being created to help with these drawbacks. One such solution is Envoy, which can act as a reverse proxy converting REST into gRPC, but that's a video for another time. Whilst I still build a good number of RESTful APIs, gRPC has inspired me to take a contract-first approach, changing the way I build services for the better. Either way, I'm interested to hear more from you. What do you think of gRPC? Let me know in the comments down below. I want to give a big thank you to Acorn for sponsoring this video. They have a really cool product which has been awesome in allowing me to share these services with you. Otherwise, a big thank you for watching, and I'll see you on the next one.